All right, welcome to part 2, problems 24, 25. So let's get to looking at the word problem itself. Problem 24, how long will it take 40 gallons of water from 70 degrees Fahrenheit to 120 degrees Fahrenheit with a 20 kilowatt immersion heater, assuming no energy is lost to the environment? So I'm going to have 40 gallons of water, and I'm going to change its temperature from 70 degrees to 120 degrees. And I want to know basically how long this will take, so time, based on its immersion heater. So we have our immersion heater, and that's just a tool. The tool can heat up the water utilizing 20 kilowatts on itself. So immersion heaters are that coil material. Some of them are just plug-ins that you can do and heat and boil water. You see them now in those immersion heater hot water pots that allow you to do tea kettle water and things like that for rapid boiling. So it's a fairly common tool that we're finding more and more. And first step is to figure out which equation I want to use. And the equation I'm going to solve for is a Q, because I want to know the amount of energy. So it's Q, the mass, specific heat, change in temperature. And I have to change my gallons in my word problem over to pounds so that I can use the specific heat of BTUs, pounds, degrees Fahrenheit. And so I'm going to lay out my first step of 40 gallons of water, and I'm going to times that by 8.3 pounds over 1 gallon. When I lay out that problem, and gallons and gallons crosses out, and I get 332 pounds. Now I can plug my information into my word problem. So it's 2 pounds times 1 BTU over pounds degrees Fahrenheit times the change in temperature of 120 degrees Fahrenheit minus the 70 degrees Fahrenheit. Fahrenheit and Fahrenheit are crossing out. Pounds and pounds are crossing out. My answer will be in BTUs. And if I plug these all into my calculator, I get So now I have 16,600 BTUs, and that's to heat my water up to 120 degrees Fahrenheit. To find out how long it's going to take the immersion heater to do it, I want to change this to kilowatts, kilowatt hours. So it's going to be 3,413 BTUs over a kilowatt hour. Once again, I just looked this up on a table to do a conversion. When I set that up, BTUs are going to cross out, and 3,413 divides into 16,600, 4.86 kilowatt hours. So now I have the amount of energy needed. So I'm going to play with my tool. My immersion heater can produce 20 kilowatts. And so I'm going to divide this number by the 20 kilowatts. Kilowatts is going to cross out, and I'll only be left with hours. Divide that into each other, and I get 0.24 hours. So if I want to change this to minutes, the next step, I'm going to erase a little bit just to make room, so is to take the 0.24 hours, and I'm going to times that by 60 minutes in an hour. Hours is going to cross out, and I will get my answer in minutes. And I get 14.5 0.59, and that's minutes. I'm going to write in my unit. All right. So that would be my final answer. So to change the temperature of the water from 70 degrees to 120 degrees, I'm going to be producing a certain amount of energy, which I converted to kilowatt hours. Then I found out how long it's going to take those kilowatt hours using a tool, and that's the 20 kilowatt immersion heater. The time it takes is 14 minutes, 59 seconds. Now we're going to take a look at working on question 25. All right, so question 25 takes an electric tea kettle with 20 degrees Celsius water 5 minutes to reach boiling. Boiling in Celsius is 100 degrees Celsius. How long will it take for all the water to boil away, assuming the same rate of heat addition? So it's going to take it 5 minutes to boil. So we have to find how many times it's going to need to boil and boil and boil till it hits a point of vaporization. So I have to look up information in order to answer this problem. All right, so the first step was to pick my word problem, and I'm going to solve for Q. Except for the information I was given is just how long it takes for the water to boil and the change in temperature. So I don't have the mass. So what I'm going to be solving for is an augmented version of the equation, which is Q divided by mass is equal to the specific heat and the change in temperature. Some of the information I had to look up in tables on the textbook is the specific heat, which I'm taking in kilojoules. So it's 4.186 kilojoule per kilogram per degree Celsius. And then I also looked up in the text the QM of vapor, so vaporization of water, and the energy needed to change 1 kilogram of water vaporized is 2,260 kilojoules over a kilogram. This I found on page 98, so I found this part on 98, and then this one I found on page 101. So that you know, I'm just looking this information up. Now I'm going to plug everything into my equation. So my specific heat of 4.186, and this is in a kilojoule, and that's over a kilogram, and a degree Celsius, and that's going to be times my change in temperature of 100 degrees Celsius minus 20 degrees Celsius. Crossing out is just going to be Celsius, so my answer will be in kilojoules per kilogram. As I times my 80 degrees Celsius times my 4.186, I get 334, and that is 0.88, and that is a kilojoule per kilogram. So now the next step is to find how many times of boiling I will need to do to vaporize all the water in the pot. And so I'm going to take the vaporization heat of 2,260 kilojoules per kilogram. I'm going to divide that number by the 334.88 kilojoules per kilogram. The kilojoules and kilograms are actually crossing out, but keep in mind it takes 5 minutes to do this. So 5 minutes to do this work. 5 minutes. There we go. As I divide the 334.8 into 2,260, I get 6.78, or 48, I'm sorry, 48, and I'm going to round that up to 6.75 to give myself less numbers. And that will be the amount of times over I would have to do over 5 minutes. So I have to do 6.75 times the 5 minutes to boiling. And that's going to give me my answer in minutes. Timesing that up, I get 33.75 minutes. That's the length of time it will take to boil away all the water that would be in the pot. So this is the amount of time it would take to vaporize the water in this problem. I know there's a lot of steps to this problem, and the key to question number 25 is really, do you, now that you've become familiar with this equation up here, know how you can manipulate the equation to get new answers, to get new ways to solve problems. Working slow, feel free to use the video as many times as you need. For exams, I will not ask you questions like number 25. I'll ask you questions more along the lines of problems 21 through 24.